Good morning, children. So last class we have discussed up to different types of chemical reaction based on nature of the rearrangement of the atoms. Another one based on the direction of the reactions. Okay, so based on the nature of the rearrangement of atoms, five types. Okay, one is combination, second one decomposition, third one single displacement, fourth one double displacement reaction, fifth one combustion reactions. Okay, so based on the direction there are two types of chemical reactions. One is reversible, another one is irreversible reactions. So totally 7 types of chemical reactions we have seen up to last classes. Okay, so today we are going to start the new topic, rate of chemical reactions. So already we know what is meant by chemical reactions. Okay, chemical reaction is nothing but what ma? Reactants are converted into product under suitable conditions. So what is mean by rate? Okay, so we have seen 7 types of chemical reactions. Okay, each reactions will occur in different conditions. Okay, different conditions. So we have to find out so which type of reactions will occur within hour or within day or within week or within month. So which type of reaction it will take long time. So we have to study this. All this information is nothing but what ma? Rate of the chemical reaction. For example, okay, so if you are seeing this type of chemical reactions, okay, for digestion of food, rusting of iron, okay, spoilage of food, okay, so these type of reactions it will take time. Okay, it will not occur, okay, immediately. Okay, so it will take time. So based on these conditions, okay, you see these examples. Okay, so you are considered as a one of the reactant is converted into products. Okay, 50% of the reactant is converted into product. Okay, another one C. Okay, another one reactant is converted into products 80%. So among two reactions, which one is faster? Which one is slow? Okay, which one is fast? B. Why? Second reactions. Okay, why? Here 80% of the reactant is converted into product. Okay, first reaction only 50% of the reactant is converted into products. Okay, the rate of the reaction A is slow, here fast. Okay, so how to define the rate of the chemical reactions? Okay, the rate of the reaction is the change in the amount. Okay, rate of the chemical reaction is defined as what ma? Change in the amount or concentration of the reactant or products per unit time. Okay, change in the concentration or amount of the reactants or products per unit time. Okay, this is the definition for what ma? Rate of your reactions. Rate of your reactions. Okay, next we will see the mathematical expression of rate of your chemical reactions. So what is the mathematical expression? Okay, so mathematical expressions means what ma? With the help of formula we will explain. Okay, so you are considering the equation A is equal to B. Okay, A means what ma? Reactant, B means product. So A is converted into product. Okay, so rate of a chemical reaction, rate is equal to minus dA divided by dt. Okay, is equal to plus dP by dt. dP by dt. So what is mean by? Okay, what is mean by A and B? Okay, concentration of A and concentration of B. Okay, concentration of A and concentration of B. Okay, concentration of A, here concentration of B. Okay, so the bracket. Okay, before that we will see the negative sign. Okay, what is the meaning about the negative sign and the positive sign? Okay, the negative sign indicates, okay, decrease in the concentration of A with respect to time. Okay, decrease the concentration of A with the time. Okay, B is nothing but what ma? The plus sign indicate, okay, minus sign and plus sign. Okay, minus sign indicate what ma? Decrease concentration with respect to time. Okay, plus sign increase the concentration B with respect to time. With respect to time. Okay, the bracket, okay, this bracket represents what ma? The concentration of A and B. Okay, the D represents what ma? The D represents what ma? Change in the concentration is extremely small. Okay, change in the concentration what ma? Extremely small. Okay, extremely small. Okay, This is nothing but what ma? Rate of a chemical reactions. Okay, so why we want to study the rate of the chemical reactions? Okay, why we want to study the rate of the chemical reactions? Okay, then only we will know, okay, how long time it will take to complete the one particular type of chemical reactions. Okay, some of the reactions it will complete within hour or within minutes. Okay, some of the reaction it will take time. Okay, so based on the durations, either we have to complete the, either we have to induce the reaction or we have to reduce the rate of the reactions. So that purpose we have to study the rate of a chemical reactions. Okay, so next one. So what are the factors are affecting the rate of the chemical reactions? What are the factors are affecting the rate of a chemical reactions? Okay, there are, okay, 6 factors are affecting the rate of the chemical reactions. There are 6 factors are affecting the rate of the chemical reactions. Okay. So next one. Factors affecting the rate of a chemical reactions. Okay. So first one, so what are the factors affecting the rate of a chemical reactions? So factors means what ma? So many factors are there to affect the rate of the chemical reactions. Okay, there are 6 factors as given in our textbook. Okay, first one, nature of the reactant. Second one, concentration of the reactant. Third one, temperature. Fourth one, pressure. Fifth one, catalyst. Sixth one, surface area of the reactant. So first one we will see the nature of the reactant. Nature of the reactants. So first one what ma? Nature of the reactants. So reactants already we know. What is the definition for reactants? A substance which undergoes a chemical reactions. Okay, that is called what ma? Reactants. What is mean by products? After the chemical reactions, we will get one new substance. Okay, that is called products. Okay, so what is the nature of the reactant? What is the role of the reactant? The reaction of sodium chloride. Okay, the reaction of what ma? Sodium with hydrochloric acid. The sodium with hydrochloric acid. The same way sodium with acetic acid. Sodium with acetic acid. So we have to see these two type of chemical reactions. Okay, hydrochloric acid is an example of strong acid. Acetic acid is an example of weak acid. Okay, sodium is an example of what ma? Metal. Okay, so usually the sodium combined with the hydrochloric acid, okay, the reaction it will fast. NaCl plus H2 gas is liberated. Okay, the same way this sodium combined with acetic acid to form sodium acetate plus hydrogen gas is liberated. When compared to these two reactions, okay, first reaction it will occur very fast. Okay, but second reaction it will occur very slow. Okay, because of the reactant. Okay, that is called what ma? Nature of the reactant. Okay, nature of the reactant. Next one, concentration of the reactant. Second one, concentration of the reactant. Concentration of the reactants. So what is mean by concentration of the reactants? Okay, so what is mean by concentration? Already we know. Okay, how much amount of the substance present in particular amount of the solvent or solution is called what ma? Concentration. For example, zinc react with 2 molar HCl, then 1 molar HCl. Okay, zinc react with 2 molar HCl and 1 molar HCl. Okay, so in which molar of HCl, okay, the reaction will fast 2 molar HCl. Why? Because of the concentration. Because of the concentration. Okay, again we may increase the concentration, the reactions will occur fast. Okay, so second point what ma? Concentration of the reactions. Okay, third one, temperature. Okay, third one what ma? Temperature. So temperature also it is one of the major part in the rate of a chemical reactions. Third one, temperature. Okay, most of the reactions go faster at high temperature. Most of the chemical reaction goes at what ma? High temperature. Because of adding of heat to induce the what ma? Breaking of the old bond. Breaking of the old bond. Okay, the reaction it will happen. So we have to break the old bond. Okay, then the formation of new bond. So we have to break the old bond. We need what ma? Energy. So we may supply the energy in the form of heat. Okay, the reaction it will occur fast. Okay, the reaction it will occur fast. For example, calcium carbonate react with hydrochloric acid at room temperature. Okay, calcium carbonate react with hydrochloric acid at room temperature very slow. Okay, so we may apply the heat. We may apply the heat in the form of what ma? Mixture. Okay, suppose we may take what ma? Hydrochloric acid in the hot condition. Okay, or calcium carbonate solution in the hot conditions. Okay, so automatically what will happen ma? The reactions rate will increase. The reaction rate it will increase. Okay, next fourth one, pressure. Fourth one, pressure. So what is mean by pressure? Already we know. Okay, if the reactants are gases, okay, this concept is applicable maximum gaseous reactants. Okay, gaseous reactants. Okay, if the reactants are gaseous, increasing their pressure, increasing their rate of reactions. Okay, increasing their pressure, okay, increasing the rate of the reactions. Okay, for example, if we want to dissolve any gases in liquid, we have to increase the pressure. We have to increase the pressure. So at the time, what will happen, ma'am? Okay, the particles comes very closer and collidal with each other. Okay, next one, fifth one, catalyst. Fifth one, catalyst. So what is mean by catalyst? Okay, it is the one of the chemical substance, but it will not take part in the chemical reaction, but it will induce the chemical reactions. So catalyst is nothing but what, ma'am? It is a one type of chemical reaction, but it will not take part in the chemical reaction. But it will induce the chemical reaction. So that is called a catalyst. So some of the reactions will occur in ordinary conditions. So we may add catalyst. What will happen? The reactions rate it will increase. That means it will come fast. Okay, suppose one reaction it will take 5 hours. We may add the catalyst. The reaction it may complete within 1 hour or 2 hours. Okay, for example, potassium chlorate. Potassium chlorate is decomposed into potassium chloride and oxygen gas. Okay, normally it will happen. So we have to complete or we have to increase this type of chemical reactions. We may add manganese dioxide. Manganese dioxide we may add. The reaction will occur very fast. Okay, next sixth one, surface of the reactant. Sixth one, surface of the reactant. Sixth one, surface of the reactants. Okay, so what is mean by surface? What is mean by surface? Surface is nothing but what? Area. So if you are taking the solid substance in a square shape or rectangle, whatever may be the shape, the same size of the substance we may take in the powder form. Powder form. Okay, so which type of reactions will go very fast? Okay, in the powder form of the reactions it will go very fast when compared to in the solid surface. Solid surface. For example, powdered calcium carbonate reacts more readily with hydrochloric acid than the marble chips. Okay, than the marble chips. Okay, because of what ma? Area also one of the main reasons for the reactants. Okay, so that's all. Okay, these are all the factors are what ma? Affecting the rate of your chemical reactions. Okay, so next getting chemical equilibrium. Chemical equilibrium. So what is mean by equilibrium? Okay, chemical equilibrium. Okay, this chemical equilibrium is applicable only for reversible reactions. Reversible reactions. Okay, it will not applicable irreversible reactions. Why? Because of both forward and backward reactions should be in equal. Okay. So how to define the chemical equilibrium? Okay. It is stated that reversible chemical reaction in which there is no change in the amount of the reactants and products. There is no change in the reactants and products. Okay, simultaneously. Okay, there is no change in the reactant and products. Okay, so the chemical equilibrium is equal to rate of forward reaction is equal to rate of backward reaction. Rate of forward reaction is equal to rate of backward reactions. Okay, rate of forward reactions is equal to what rate of backward reactions. Okay, for example, okay, if you are taking the calcium carbonate, okay, calcium carbonate is decomposed. Okay, calcium carbonate is decomposed into calcium oxide plus carbon dioxide. Calcium oxide plus carbon dioxide. Okay, the rate of decomposition of calcium carbonate is equal to okay, the rate of combination of calcium oxide and carbon dioxide. Okay, the rate of decomposition of calcium carbonate is equal to the rate of combination of calcium oxide plus carbon dioxide. Okay, carbon dioxide. Okay, so when both forward and backward reactions obtain the equal, that means what 50% of the reactant is converted into product, again 50% of the product is converted into reactant. So at that time it will obtain what chemical equilibrium. Equilibrium means what both also same. Okay, suppose okay, it may applicable for gaseous state also or water also. So if you are taking the container water, okay, so we may apply the heat. What will happen? Okay, the water is converted into water vapor. Okay, water vapor. So when it will obtain the equilibrium? Okay, when the amount of the water is equal to amount of the water vapor. Okay, when the amount of the water is equal to when the amount of the water vapor. That time it will obtain what chemical equilibrium. The same way physical equilibrium also is available. Okay, physical equilibrium also is available. Okay, the same concept. Okay, the same concept. Okay, physical equilibrium is what state of physical change which the volume of the all the phases remains unchanged. Okay, the volume of the all the phases means what solid, liquid and gases. Okay, it will not change, remains same. Okay, so next one, characteristics of chemical equilibrium. What is the character? CHARACTERISTIC, characteristics of chemical equilibrium. So first point. So what is meant by characteristics of chemical equilibrium? First point, in a chemical equilibrium, the rate of the reactants. Okay, the rate of the reactants. That means what the rate of the forward reactions should be equal to rate of the backward reactions. Okay, rate of the forward reactions is equal to rate of the backward reactions. Okay, second point. Okay, the observable properties are pressure, concentration, color, density, okay, viscosity, okay, this, okay, etc. Okay, the remains are unchanged. Okay, the remains are what the system remains are unchanged, so it will not affect anything. Okay, it will not affect anything. Okay, that is called a second properties. Okay, third one, the chemical equilibrium is a dynamic nature. Okay, dynamic equilibrium. So what is meant by dynamic equilibrium? Because both forward and backward reactions occur continuously, okay, even though it appears static externally. Okay, so fourth one, Okay, last point. In physical equilibrium, the volume of all the phases remains constant. Okay, in physical equilibrium. In physical equilibrium, the volume of what ma? Remains all the phases are constant. Okay, so these are the 4 points are what ma? Characteristics of chemical equilibrium. First point, both the forward reactions and backward reactions should be equal. Second one, observable properties. Okay, observable properties are what ma'am? System remains unchanged. Okay, third one, okay, it is an example of what ma'am? Dynamic equilibrium. Fourth one, physical equilibrium. In physical equilibrium, the volume of all the phases remains constant. Remains constant. Okay, so that's all. It's enough. Okay, today classes is enough. So next class we will see the ionic product of water. What is mean by pH? What is the role of pH in everyday life? Next calculation of what ma? pH and pOH. Okay, that's all. This lesson is over. Okay, one more class is enough to complete the this lessons. Okay, so thank you children. You have to study up to third portions. Okay, thank you.